All right, folks, it is 9 o'clock. That means I'd like to officially welcome you to class. I hope you're doing well on this Monday morning. So right in front of you, this challenge question, fairly straightforward, asking you to express this function using ordered pair notation. So then we've just got to understand two of the methods of two of the types of notation that we learned last class, one of which is just this graph. This is, you could just call it graph notation. And the other is ordered pair notation. So if we choose one of our points, let's say we're going to start with this one, our leftmost point, we want to know the x and y coordinates of it. Okay, and it's as simple as that. So for that point there, your x coordinate goes first, and it's -3. And your y coordinate goes after that, that's 6. So you just do that, put it in between brackets, write another comma, and then do the next one. And you don't usually just write it all on one line, but if you run out of room, we'll continue down here. You'll get sick of writing brackets and commas, but that's okay. All right, so spend another few minutes working on that, and then we'll continue on. All right, folks, we're gonna keep going here. It's good to see you. I hope that yeah, like I said, I hope your weekend is good. I want to jump right into things here. We're gonna move on to 3.3. It's all about linear equations. And some of the key ideas here. First, defining these terms, the word expression, the word equation, and then of course, what is a linear equation in particular. And then how to graph linear equations of two different forms. So how to do it by hand, pen and paper, right? Pencil and paper. Should be using pencil in math class. Okay, so we're going to start by looking at page 131, I believe, 131. 131. How about 130? 130. On page 130, we're just going over those expressions or those terms that we talked about. So first, an expression. It's a collection of numbers, variables, and operation signs. Importantly, there are no equal signs, okay? No equal signs. Here are some examples, okay? An expression can even be radical by having a square root or another radical symbol. And we can have variables squared, variables raised to a power. Of course, we can also have an expression that's really simple. It's just one number. If it does have an equal sign, then of course that becomes an equation. And importantly, equations can be solved. Okay, so this is a very, very simple equation. In fact, if we were trying to solve it, we're already there. We've got y equals 2. Okay, there's only one variable, and that's okay. In these next three equations, there's two variables. They've chosen x and y for both of them, but equations can have variables with other names as well. So here we've got three equations, but I want you to look at how these two blue ones are different from this orange one here. Okay, so what makes D stand out? What makes this orange one different from the two blue ones? Any thoughts? All right, if we're looking at these two blue ones and this orange one, what makes the orange one different? The exponent, yeah, thank you, thanks, Evan. So we see that this orange one here has an exponent, and it's got y raised to the second power here. Okay. And so we can call both of these Since they don't have an exponent on either, on any of the variables, and since they don't have something weird like this where the x is in the denominator of something, okay, so this would also eliminate it from this category, we call these linear, okay? This is linear, and this is linear. And they're called linear because if they are graphed, well, yeah, just like as you would expect, they're going to be graphed as a straight line. Whereas this orange one here, it would not be a straight line. It would look something like a sideways parabola, something like that. All right, so they are linear. And that's the last thing that we're discussing here. Linear equations. Okay, so it can be written in this form. And the important thing about this form is that A, B, and C can be numbers. They can be any numbers. They can even be radicals, or they can be really huge numbers, or decimals, or fractions, right? A, B, and C can be those numbers. But the X and Y, importantly, should just be normal. They can't be X squared or Y to the power of -7. Okay, it can't be anything like that. So we're also mentioning all linear equations are functions except a vertical line. Okay, except a vertical line. So that would be this one here. Okay, if we graph this, x equals 3 or something like that, we'll see that it's not a function. So I'm just going to graph this bottom one. I'm going to graph C here, 2x plus 3y equals 5. I'm just going to do that using Desmos here. 2x plus 3y equals 5. And there we go. As we suspected, it's a straight line, right? It's a straight line. Even if I change 3, maybe I'll put on projector mode. Even if I change 3 to, let's say, 8, right? It's still a straight line. Even if I change it to a decimal, it remains that straight line. Even if both of these were like the square root of 2, it's like, I'll change this to a square root, right? Square root of 2 times y, okay? That square root of 2 is still, or the square root of 6, let's say, those are still just like numbers, right? It does become a problem. Watch the difference. When I make this instead of x, if I make it the square root of x, we can see that it's no longer a straight line, right? So whenever if I make any sort of modification to this x, to the x variable, if I made it x squared, no longer a straight line, right? So the variables can only be vanilla, normal. And we saw as well, we can have a very simple linear equation by doing something like this, y equals -1. And that's a function that passes our vertical line test, the blue and the red there does. But if I've got something like this, x equals 2, that's straight up and down, that absolutely fails our vertical line test, right? Because whenever I bring that pencil to that green line, I can see that there's a lot of points that are intersecting with the pencil. Any questions so far? Questions regarding any of that? All right. We're going to move on to the next page here. This is all about graphing these, graphing linear equations. So just like we saw them get graphed using Desmos, we want to be able to do it without Desmos or graphing calculators or anything like that. So if we've got something in this form, this is called general form. Excuse me, if I'm not mistaken. We can start with a couple of really nice first numbers. So we're going to find the y-intercept with x equals 0, and we're going to find the x-intercept when y equals 0. Right? If we imagine that we have some linear equation, you know, they're intersecting the x and y axes at these 2 points. We don't know, for example, if we look at this x-intercept here, we don't know what the x value is, okay? So the x value is a question mark. It could be like 2 or 5 or something. We don't know what it is, but we do know what the y value is because it's not up, it's not down, it's not above the x, it's not below the x, it's right there at 0. So in order to find what our x value is going to be, let's just plug in a y value of 0. So that's what they're suggesting here. Similarly, at the y-intercept, the x value is 0 because it's not to the right, it's not to the left, but it's right there at 0. And we can work to find our y value. So you can get those 2 points and then get a third point. You just pick another value for x and solve for y. So, for example, what they've done in, okay, so we're asked to graph this equation, this simple equation, and they've picked 3 points and put them into a table of values. This is great. This is a really good way to organize your work. 2 of the points, one is when x is 0 and one is when y is 0. And the other one they chose just for fun, just for funsies, was this one here, x of -2, right? And they're doing their work to solve that here. So as you can see right here, they're solving when x equals 0. That's an x. So they're replacing x with 0. And then this next step, we would have to, well, that just gets canceled out, right? So you're left with just 2y equals 6 or y equals 3. Okay, this one here, this is when y equals 0. What's nice about choosing these ones when the variables are 0 is that they end up canceling out. That canceled out and that canceled out because 2 times 0 is just 0. And then finally, this one, they just chose one when x equals -2. That can be anything you choose. All right. From there, you know, they completed their table of values and then they plotted those points on the graph. So 0, 3 is right there. And 2, 0 is right there. And then -2, 6 is right there. And then just drawn a straight line connecting them. They've made a note here. If a straight line does not go through all 3 points, a mistake has been made and you should check your work. Okay, so it should go through all 3 points like that. And then we have one more note here because these equations will continue to go off into infinity. So we draw these arrows at the end. If it didn't have the arrow at the end, it kind of implies that it ends at that point. It ends wherever your drawing ends. Questions at this time? All right. So this is just a summary of stuff that we've learned already, which is domain, which is range, etc. Now we have this type of linear equation as well, and this is very common. We're going to learn more about it in a bit, but we call this the slope-intercept form. Slope-intercept form. And it's called that because the m value represents something we call the slope. It's how steep an equation is. And the b value represents the y-intercept. And just to illustrate that, I want to look just right below here. We've got this equation. And I want you to look at these two numbers. We've got the -2/3 and the 4 here. And just, of course, we just talked about where, hey, if we've got an x value of 0, that's going to be how we find our y-intercept. So this is when our x value is 0. And so that's what we're starting out with here, right? For this first batch, we've got x equals 0. And notice what happens, right? This slope part, this negative 2/3 part cancels out. And of course, it leaves us with just the number 4. So when x is 0, our y value is 4. And that was this number here all by itself all along. So with this form, it's really nice because this number that's by itself will always be the y-intercept. Okay, always.
So y is x 0?
Y is x 0. We're picking numbers. We've picked numbers that will help us graph this. Okay, so we're just building our own table of values. But just to kind of have a look at that again, like let's say we've got an equation y equals mx plus b, right? So what I've done is I've put in those variables m and b, and I can add those into Desmos and turn them into sliders. And so we can see that right now our y-intercept is here at 1. If I wanted to raise that up, if I wanted to make the y-intercept maybe, let's say, around 3 instead, what would I change, m or b? If I wanted to bring the y-intercept from here all the way to up here, what should I change, m or b?
Change the b, right?
Yeah, change the b. So if I slide this b value up, it causes that y-intercept to change. So I can replace that b with a 3, right? This is just saying, hey, my m value right now is 1, and my b value is 3. So it's an equation that looks like this: y equals 1x plus 3. All right, let me put the m and the b in there again. I'm going to bring that b down to 1 more time. I just want you to see what happens when I change this m value. If I increase m, we talked about how that m value was slope, which is kind of like the steepness of this graph. So I'm going to change this m value. I'm going to increase it, which means I'm increasing the steepness. I'm increasing the steepness. I want you to predict. I want you to have a picture in your mind what's going to happen when I increase m, which is increasing steepness. Picture it in your brain. Okay, use your brain. Okay, you ready? I'm going to increase steepness. Here we go. Okay, is that what you predicted would happen? Does that increase steepness? Okay, good. So it got steeper, right? I guess it's really easy to kind of think about, right? We're getting steeper as we increase steepness. Okay, good. I'm going to set it back to 1. Okay. Now I'm going to decrease steepness. Okay, predict. Use your heart this time to predict this. Okay, what is your heart telling you? I'm going to decrease the number. Okay, what is your heart telling you? Are you ready? Okay, there you go. Is that what you predicted? It gets less steep. This is easier for a truck to drive up. Okay, and we're very close to 0 here. We notice we're getting closer and closer to a straight line. When we set that slope to be 0, we have no slope, right? Slope is 0, we have no slope, and so it's just this flat line. And then, of course, we could even go negative, and here's what a negative slope looks like, right? Instead of going up and to the right, it goes down and to the right. And if you want to, you can just hit play on this thing and play on that thing. And, you know, just kind of, we can just watch this for a little while. All right, that's enough. Without popcorn, it's not the same. Okay, so we've done this, going back to this, our example student is, you know, continuing to plug in x values. They've just picked 3 somewhat randomly that will fit on their graph and found the values there, right? I suppose one important thing is that they did pick multiples of this value, this denominator, right? This made their calculations easier because when we've got -2/3 times 3, we realize that the 3's just cancel out and we get nicely -2. Over here, when we have 3 and -3, again, our 3's cancel out, right? We end up with whole numbers rather than fractions. Okay? So that means, you know, when you're dealing with an equation like this, where you've got this, you can pick any x values you want, but primarily, please pick x of 0, and then pick things like this. You can pick x of 3, 6, 9, 12 if you want, right? Because it's multiples of 3, or -3, -6, etc. Okay, multiples of 3. All right. And finally, of course, they've plotted those points. Here's one, and here's one. Got out the ruler or straight edge or the edge of their phone, which I've seen many students do, and drawn a straight line. Yeah, so that's it. A lot, folks. I should have said this at the beginning of class. Are you listening? Are you listening? A lot of Math 10 is all about these linear equations, okay, and making these graphs and like things like that, understanding them. Okay, so you know, not for the rest of the school year are we doing this, but for the next few months, we're going to talk about linear equations. Okay. Oh, by the way, speaking of what's coming up next, did you know next week is next week on Sunday? That's November 11th. That's Remembrance Day, and the Monday is a holiday in lieu of it, and then you have that week off from live stream classes and face-to-face and things like that. So you don't have live stream classes next week. Okay? Okay, good, great. All right, I want to do an activity with you folks. This is a Desmos activity. I don't think we've done this. Let me know if we have, but actually what I want to do is just kind of show you what it's like first, just so that we've got, let's see, sure. My name is Green Onion. That's my name. So I just want to show you what this activity is like. Okay, have you done one of these? Have we? I don't think we did one in class, did we? No. These are fun. You got to try to get all the stars, right? So you hit launch, and then those balls drop, and you have to find the you have to hit all those stars. You can see if I do, this is round 2. I got to change something. I got to make a change. I got to bring that line down. So what can I do to lower that straight line there? See, it's right here. This is the expression, or this is the equation for it. What number could I change?
1.
Okay, so I can change this 1. You know, if I increase it, if I make it 2, the change that I saw was that blue line went up. So of course I'm going to have to get something a little lower, -1, -2 maybe. That should do the trick. Bingo. Okay, success. I do want to, oh, this is just saying if you need to reset, follow these instructions, right? You can hit this wrench and hit reset. Okay, I want to show you this, because this is new notation. But these brackets here remind us of domain and range, right? These curly brackets. And so here we're saying that x has to be less than 4. If we launch it, we can see that those balls don't make it quite far enough, right? So let's try increasing x to 5, for example. Almost, right? We're just lengthening that line. Okay, we got it. All right, is that clear? So you can modify your lines that way. What I'm gonna do, copy link address, I'm gonna put it in the chat. You know, I never make these things worth points because they're just kind of fun. But I don't know, maybe I should. All right, well, anyway, just go ahead. You can get started on it. There is the link in chat. It's that real long link there. But you can click on that. You can head to that Desmos activity and work on it. Do you guys want to be split up into breakout rooms just so you can chit chat and stuff? Doesn't matter. Yeah. No. I don't want to chit chat. Alternatively, folks, you can do this. Go to student.desmos.com and type in that license plate there. Right now we've got green, onion, and Noah. Oh, and orange. Okay, I should be, I wonder if I can change these people's names. Okay, good. There are challenge questions at the end here. These are fun, but they're tough, okay? So try your best with these challenge ones. And please do, if you're asked to type something out, please do type something, even if it's quick. Okay? All right, we'll do breakout rooms. You guys can get working, get started. We'll just do 2 big breakout rooms. How about that? Here we go. All right, folks, welcome back. I really like these Desmos activities because they're kind of fun, right? To try to solve these puzzles. It's like a game, right? But I also like them because you can go at your own pace, and no matter where you end up, you know, you've learned something or you've practiced something, right? So whether you just made it to fix it number 4 or whether you made it like to some of the challenge questions at the end, that's fine. That's good. The fix it number 4, this was a good one. We saw like a lot of different types of solutions, right? Perhaps one of the most basic, but one that works really well is something like this, where you can cut off the blue line, the top line, pretty early, and then you just produced another line right below it. Nice and simple and works well, right? You can try something like this. This is kind of what I was trying too. And this one will, yeah, that one does it, right? So it kind of bounces back again. This one, okay, did this one work? Yeah, okay. So kind of just had to catch it there at the end. Maybe it wasn't even necessary to have that red one there. Let's see. No, okay, so you do, whoops, okay, I don't think it's permanently changed. Okay, good. And then verify, let's find another one to just have a quick look at here. Verify number 4, right? So let's see. We wanted to try to hit all those there. We're trying different slopes, and we find that you can grab one that seems to do the trick. This is 4/2, which is also the same as just 2. Some of them go over, some of them go under. I didn't realize you could make 2 lines. Yeah, that's part of the puzzle. You can just kind of copy and paste and start building your own lines. Okay, and then these challenge ones. Let's just have a look at some of the challenge ones, some of the attempts that were made, right? So for this one, you've got to try to hit all those lines there. It looks like this one, is one that, okay, we got it, right? We can split off at the top, and then they bounce away and funnel back, right, to reach that bottom one. Here for this one, we're trying to make it go through and then hit up these next ones. So this one, we can see it's going to hit those first two, but this student here was able to make it go through. Yep, both of them. Okay, so yeah, some good challenge ones there. All right, Math 10 students, good morning. Today, I'm going to introduce to you a project that I want you folks to work on. All right, and it's a project in multiple phases. I think it's an interesting project. It's one that I've done very similar things in the past with other Math 10 classes, and students come up with some cool things that they can do. So I'll make sure that this project that you can see it on your Canvas page. We're going to start with a human behavior proposal. Okay, so that's the first phase of this project. So you can navigate to the Canvas course and you can view it there. And we'll just kind of go through it together here. Can you guys read that okay? Is it big enough? Okay. So this is a human behavior project, exploring human behavior. So let me just read a little bit here. Many professions dedicate themselves to studying human behavior and activity. The field of human physiology, for example, studies the physical responses to stimuli, while psychology focuses on the mind and behavior. Professionals can find conclusions to new ideas by conducting tests with large numbers of human subjects and finding correlations. It is your task to investigate how varying something can affect human behavior. And by human behavior, we're just kind of just saying like any way that humans behave or act or what they can do. So this assignment will focus on one independent variable, that's something that you control, and one dependent variable, which is something that you measure. For example, you might choose to see how caffeine consumption affects response time. In that example, the amount of caffeine could be the independent variable, and the number of seconds it takes a person to respond could be the dependent variable. Both variables should be quantifiable, and that just means that they should both be able to be measured. So there's a couple points here. You could consider independent variables revolving around age, sleep, food, score on a simple test, or others. You could consider dependent variables revolving around completing a timed simple task, completing a physical task, heart rate, breathing rate, simple test, or personal preference on a scale from 1 to 10, for example. All right. So, for example, what some students have done in the past, what I've seen students done, a pretty classic example is how you can do a hearing test. And so certain frequencies, you know, when you start to reach high frequencies of notes, you become unable to hear the sound. And that is something that changes with age. For example, someone like me, it'll be harder for me to hear some of these high frequencies compared with some of you folks. I wonder if I can, there was a way I saw to share sound. That's okay. That's okay. Leave computer audio. What does that mean? Anyway, maybe we'll see if we can do that next time. So you could, for example, find some people where you would be, and they would be willing to test their hearing, and you could plot that versus age. Or some students a couple of years ago, they did this soccer activity where they asked people to kick a ball after having spun in circles. So first you kick a ball and you can measure how far that ball will go without spinning. And then you could spin 5 times and see how far you can kick the ball after spinning 5 times. And then you spin 10 times and see how far you can kick the ball. There's this example about caffeine and response time. So for example, some students in the past, they created this quick little like quiz, right? And students have to try to solve the quiz as quickly as they can. Well, is that easier to do before drinking coffee or after drinking coffee, right? Or before eating sugar or after eating sugar? So it can be something like that. Are there questions at this point? So this first phase, right down here, it says, submit your proposal by Friday, November 9th. So that is this Friday. That's this Friday. I'm hoping that you can have this. It's a small phase here, this first part. Decide what you would like to study. Write a sentence that describes your goal. For example, this assignment will investigate how blank affects blank, how caffeine affects response time, how spinning around affects how far you can kick a soccer ball, how age affects hearing, okay? Name your independent and dependent variables. Describe how your variables will be measured. So can you come up with a method? Will you need to measure time? Will you need to create some sort of test? Will you need to find heart rate? Describe this in at least 2 sentences and include any tests or materials that you need. So you need to be prepared for your method. Okay, and then submit your proposal by Friday, November 9th. Phase 2, this is where you're conducting the study. So you'll need to ask for volunteers, keep detailed records in a chart, and you should have at least 30 points of data, okay? So for example, if I was doing that soccer study and I wanted to test for each person no spins, so they're not spinning and they kick a ball, 5 spins they kick a ball, and 10 spins and they kick a ball, that's 3 points of data per person. Well, I only need to survey 10 people. Does that make sense? Do you see what I'm saying? Yeah? Okay. It can be family, by the way, that's fine. Yeah. So yeah, you can do that. I'm saying try to get the most accurate data you can. If the data doesn't look like what you expected, that's okay. It's not your job to change the data to make it look nicer. And this is just an important reminder. Whenever we're doing scientific experiments and stuff, we shouldn't be changing data even if it looks like, well, unexpected. Finally, the way that I'm hoping you can present it, your findings should be presented as an infographic, which is like a digital poster, or just a poster. But we'll do this in class. We'll go through this in class. We want to plot our data onto at least one scatter point graphs. Excuse me. We'll use Google Sheets for this. And then we'll come up with, we'll do all this stuff later, align a best fit, and then writing a concluding paragraph. We'll go over those details. Your poster should be completed by December 1st, which is about a month away. Just in time for, well, not just in time for Christmas, but yeah. Then there's a rubric down here to give you some direction. All right. Are there any questions about that? All right. You know, I was going to assign some textbook homework. I don't think it's necessary. I think a better use of our time right now would be to give you guys some time to just brainstorm a little bit and see if you can come up with some things that you could measure, right? See if you can come up with what are some things you could measure. So I've given you some examples here. Heart rate. You could measure heart rate and think about things that could affect heart rate. How does running affect your heart rate? How does watching a scary movie affect your heart rate? Okay, so things like that. I'm going to split you up into 3 breakout rooms now, and I want you to brainstorm. See if you can come up with a list of things that you could measure. Is that clear? Are there questions before I send you into breakout rooms? All right, we have about 10 minutes of class left. So spend the next 10 minutes brainstorming things that you could measure. There we go. You got your breakout rooms. Head in there. I'm going to hit up those rooms soon.